Welcome to the dridhOn channel. Here we are discussing about PCB introduction with industry experts. Let's start.
My screen.
Okay, ma'am.
Yeah. So here it is. Say example. We'll start with the theory session. 2 to 3 session will be the theory session. What is PCB and why we are using PCB, and what are the characteristic of the PCB, and what are the layers will be there in the PCB. That everything I'll be explaining you. Okay.
Okay,
so
ma'am. Okay,
we'll just go with what is PCB. PCB is most commonly the abbreviation for PCB is a printed circuit board or printed wire board, printed card, printed wire cards also they will be telling it. Okay, so what is why PCB is used especially? Hello, do you know why PCB is used?
ma'am, it is
Hello?
used for both testing, IC testing, ma'am. And we are using for every TV, LED, TV, washing machine, in everything we are using PCB, ma'am.
Correct, yeah.
It is easy to amount a large amount of easily என்ன சொல்றதுன்னா பெரிய இதுல கூட இத வந்து டம்ப் பண்ணிடலாம். பெரிய சர்க்யூட்னா கூட இதுல PCB ல வந்து ஈஸியா டம்ப் பண்ணிடலாம்.
Yeah, correct. So just say example, now you are doing the PCB. Why you are doing the PCB? So input for the TV or anything, if you take, so input is line voltage, right? So that is the electrical supply, 230 volt. If you touch any 230 volt, people get shocked, correct?
Yes, ma'am.
So to avoid that, people, they use wires, correct, right? So wires, they cannot join it just like that. Now electrical circuit will have high current, so thicker wire we are taking. So whatever we in the nowadays the technology, it has come in the micro nano current amps rated technology has been enrolled. So in such a way that the IC each pins will be very minute, correct? So you need to place it in somewhere else, correct, right? So that has to be connected from one point to another point. It has to connect to component, correct, no?
Yes, ma'am. Yes, ma'am.
So that's why PCB is used. Okay, see example, in olden days people they use this general purpose board they have used. So that will be connected, the what is that, buck strip will be connected. From the buck strip they will be taking the wires and then ending into other connections. So this makes a very tedious process, correct, right? Where exactly which wire it has come, we don't know, correct, right?
Yes, ma'am.
So to avoid that, what nowadays PCB they have used, this IC is there. So we are taking the trace like this. So from this pin, it is connected to this. So from this pin, it is connected like this. Okay, understood,
Okay,
right? Like this,
yes,
it is connected. So from one point to another point, it is connected. From this point to, if it goes to bottom, in the sense we will place a via, and then it will take to bottom layer. Okay, so that's why PCB is used. So before like in 2000, say example, in 2000 people they use the PCB as a big boards. Okay, say example, computers are very big, correct, right? Now computers has come the mobile phone size, tablet, yes, and other stuff, correct, right?
Yes, ma'am.
Yeah. So now say example, relays, why we are using this relay, we will be using for switching the NONC connection. Say example, this light to on for high current only. Nowadays we are using the relays. If you want to make it for switching for low current or low voltage and all, use transistor, correct? Hello. You are able to hear me?
Ma'am, your voice is breaking, ma'am.
1 second, I'll just come 1 second. I'll change.
Okay.
Okay, is it audible now?
Yes,
okay now?
Okay, ma'am.
So now, before we were using the relays for switching small circuit, small supply lines or anything. So if you want to amplify, we use relay for switching. But nowadays we can use transistor, IGBT, MOSFET, with the high current also we can use it. So the cost wise and then the size of the component, it has come down. Correct, right? Hello?
Okay. Okay. Yes, ma'am.
So
Yes, ma'am.
size and then cost of the component, electronics component has come down. So due to that, overall your product has come down. In size of your shape has come down. Correct, right?
Yes, ma'am.
So now, before in nowadays with the tablet we can able to connect keyboard and then we can able to work it. With the
Yes,
touchpad
ma'am.
also we can able to do it. Even with the touchpad we can able to write it, and then with the pencil we can able to write it. Touch display has come. So everything it is there. It is similar to the mobile phone, tablet, even computer
Okay.
also comes. Correct, right? So what we can do is say computer and then notebook. What is the difference? You know?
Yes, ma'am.
What is it?
Uh,
Tell me. Hello? Hello? Hello?
ma'am, can you hear me, ma'am?
Yes, yeah.
Okay, ma'am. Ma'am, computer we cannot move from one place to another place, ma'am.
Okay. Mm-hmm.
But it is tablet is we can use. We can keep it with us, so we can move from one place to another. And we have a computer.
Laptop. Okay, 1 second. Laptop to notebook. What is the difference?
Laptop, notebook. We can notebook, laptop.
No, not notebook means we will have in computer notepad, notebook, notepad, right?
Yes, ma'am.
It's similar to the laptop. You know, for office purpose they use.
Yes, ma'am.
So what is the difference in the sense we can able to fold however way we want it. We can use it as a notebook, normal rough note and all is there, right? With that also we can able to write it and then save the files. And one more thing is, normally everything it works in Wi-Fi, correct? So Wi-Fi everywhere it is available. So Ethernet is not required for that.
Yes, ma'am.
Only charging port is sufficient. You don't require mouse also.
Okay, ma'am.
Okay, so you have touchpad. Yeah. So what it is in the sense, say example, notepad. This notebook Pro it has come, right? So what is the difference between notebook Pro and then laptop is just you will not have the display laptop. You will have smaller size. You can able to write it and then save it. And the only thing is Ethernet and other peripherals like keyboard, Ethernet, HDMI port, that everything it will not be there. Okay. So if you want that, you have to use external adapter. Say example, whenever you required, if you want to connect it to your monitor to bigger screen, then you can use HDMI port. So for that, USB to HDMI converter will be there, so that you can use it. Okay.
Okay, ma'am.
Pratyusha.
Yes, ma'am.
Yeah. If you don't understand, please let me know. Okay.
Okay, ma'am.
Yeah. So that is how this is there. So the cost wise it has come down, and then electronic prevalent consumer goods, and then it has reduced the size of manufacturing cost of electronic products and looks better solution. So that's the reason PCB they started using. So this is an example for the LED. Before LED means for decoration our home, any functions comes, they used to put the serial bulb, right? Instead of serial bulb, nowadays it has come with the LED strips. Correct, right? So it will automatically change the color for 5 minutes once. It can make it like a flower kind of shape. So we can able to make it. Hello?
Okay, ma'am.
Yes,
so
ma'am.
we can able to make it. So for that, we need to do some programming. So for that, we will have this IC. So this IC, if we give some 5 volt or 3.3 volt here, this will be converted and then it will give some supply voltage here. So based on that, we can able to get the LED blinking can be happen. Okay, right? So this is a simple circuit where for the decoration and all people, they use this kind of things. So by default, the programming might have done for this, and automatically the LED bulb means glowing with respect to inner cover should be dark yellow, and outer cover should be dark yellow with reddish. And then next layer is like pale pink. Okay, and then next layer is dark pink. So something like that, different colors, we can able to do it with respect to this kind of board. Understood, right? So how the printed circuit board has come in the shape is they use the lines, pads, and then various points to connect from one point to another point, from the one component to other components. For example, from a connector to power supply section. Something like that we can able to connect it. Okay, so this is what the PCB overall thing, why PCB is used, what is the use of PCB. If we make the PCB, what are the things we can able to do it, how the component can be placed it, so we can able to see it here. Okay, once after doing the design, the design, once we are done, once we place the component accordingly, this is how this PCB, assembled PCB will be, it looks. Okay, understood, right? So next is composite layer. Say example, composition is it's nothing but a layer stack up. So layer stack up, why it is required is it is a very important key parameter for the PCB. Say example, when you do 2-layer PCB, so what are the layers will be there? The PCB. Okay, so people they tell 2-layer PCB, single layer PCB. Okay, so what is layer stack up? Say when you want to do any routing. Okay, so especially when you are doing any routing, so in that scenario, how the conductivity will happen. So from one point to another point, the conduction need to be happen in the sense electrically it has to be connected. Correct, right? So that the continuity will be there from one end to another end. So for that, which is a good conductive material?
Copper.
Yeah, correct. So copper is a good conductive material. So normally people they use copper. Why copper? Other things also is there, right? Why only copper? Why not other material? Hello.
Yeah.
Hello. Am I audible?
Yeah.
Yes, ma'am.
Yeah. Why only copper? Why not other material? You know? Okay.
Less conductivity, ma'am.
No. The material wise, this has good. It's like a cheap and best one thing, easily available. Okay, and then we can reutilize the copper when we melt it. And other conductive materials are little costlier. Say example, gold is a conductive material. Okay, iron also conductive material. Iron, if any moisture if it comes, so because of that it get rusted and then it will eroded by itself. That will go. Correct, right?
Yeah.
Hello.
Yes, ma'am. Audible.
Yeah. So due to that, people they do use iron and then gold. Gold is very costlier. Correct, right? We cannot use gold.
Yes, ma'am.
Okay. So that's the reason people they go for copper. And copper is a very good conductive material, and this has a very good lifetime. Okay, lifetime product it is. Not only this this generation, even if you go for more, I mean, it's like 6th generation, 4th generation of the electronics industry, or 5th generation of electronic industries, if we go, right? Then copper is the one good conductive material, and recycle we can able to do it. Okay, the cost wise it is very less. That's the reason we are using the copper layer. So first layer in the PCB, you are able to see the silk screen. Okay, first layer will be silk screen. Below the next silk screen layer will be solder mask layer. Okay, the below solder mask layer the copper layer will be there. Okay. Next, copper layer, substrate layer will be there. After substrate layer, once again, if you come down, next after substrate layer, copper layer will be there. After that, solder mask bottom, silk screen bottom. So this means it is a 2-layer board. Okay. For 2-layer stack up, first silk screen layer, top silk screen, bottom silk screen will be there. So for 2-layer, first silk screen layer, silk screen top. Okay. And next layer is solder mask top. Okay. And the next layer is top layer. Okay. And then next layer is substrate layer, FR4 material. Okay. And then next layer is bottom layer. Okay. And then followed by next layer is solder mask bottom layer. I'll write down here. Solder mask SMB. Okay. And then next layer is solder mask silk screen top bottom. Okay. So from bottom side, this is how it will be. Okay. So why in between copper layer, one substrate layer is there? You know why?
Water resistant.
In between of top layer and bottom layer, why substrate layer is placed? Hello?
Yeah, ma'am.
Am I audible? Hello?
Yeah, ma'am, audible, ma'am.
Yeah. Why substrate layer is placed? You know?
No, ma'am.
See, both are conductive material, right? So if it touch together, it will become short, no?
Yes, ma'am.
So why we are routing this copper layer will be separate, top layer will be, it means, say example, now this is positive line, this is negative line. So if it touch together, the board may get short, right? Hello?
Yeah, ma'am, yeah.
So that's the reason we use substrate layer in between. So, and one more thing, why on top of top layer, solder mask layer is placed? Why not silk screen layer? Hello?
Don't know, ma'am.
Okay. Okay, let me explain. Okay. So why on top of the top layer, why solder mask layer is there? Again, it is a solder mask. If we, it is a conductive material. Both the side it will be there, right? So by mistakenly during testing or any other time, if it is conductive material, if it touches your board, that because of that it will get short circuit. And one more thing, to protect your PCB. Okay, so we are applying this solder mask like different color, green color, and this purple color, and red color, white color, black color, different color solder mask we apply. Okay, so your traces will not come out. As days goes on, the copper will not give, it won't sustain. So what we are doing is on top of that, we are pasting one more layer with the paste gum so that it will touch with the board. Okay, so that's the reason we are applying the solder mask top, and on top of that silk screen layer we are doing. Why silk screen layer is to visible, to read out your numbers and indication of your connector, which is positive, which is negative, and which is the orientation of your ICs, and then what is pin numbers, like indication of RX-TX pin. So something like that we will be printing on top. So if I print the silk screen layer on top of the solder mask layer, if I do it, so you may not be able to see it. Correct, right? Visually you cannot able to read it out, what is what and all. So that's the reason silk screen layer is on top, solder mask layer is on bottom, and then next is copper layer is there. And below the copper layer, substrate layer. Understood, right? Hello. Hello.
Yeah, ma'am.
Yeah.
Understood, no?
Yes, ma'am.
Yeah. So what is substrate layer? We'll see what is substrate layer. So substrate layer is nothing but FR4 layer. Okay. So why substrate layer is used? Say example, one condition. Okay. So you are using your mobile. You are using from top floor. Okay. From the terrace, you are using your mobile. So from there, if you put your mobile down, so how exactly your mobile will break or how it will be? First question is. Obviously it will break, right? So first damaging part will be to your mobile is which one?
Display.
Display. Okay. So first you will change the display or entire mobile you will change it. First display only, right? People, they don't worry about inside what is in the PCB, whether it got damaged or not, they will not worry about, because display is a glass kind of material, crystal kind of material. Correct, right? Hello.
Yeah,
Yes,
ma'am, audible.
ma'am.
Yeah. At least sometime you please respond. I thought my network issue. And now it is okay, right? Continuously you are able to listen me, no?
Sometimes it's breaking, ma'am.
Sometimes?
It was breaking.
Oh, shit. Whenever you get break, right, you please give answer.
Okay.
Okay? Yeah. So, yeah. So why, first thing we will be checking is we will be seeing the your display on your mobile. Okay. First we will change the display and then PCB will be, it will work fine, because why it is because of this material. Okay. FR4 material. So your FR4 material, normally the standard PCB thickness will be 1.6 mm thickness. So 1.6 mm thickness is nothing but 1 centimeter. So 1 centimeter thickness, it will be there. Okay. So 1 centimeter when we consider, so in that scenario, your PCB thickness is very thick so that you cannot able to bend it. Okay. Unless if you give hard pressure to that. Okay. Then only the PCB traces will break, or else it will be very good. So that's the reason we are using this FR4 material. So this FR4 material gives this value for the FR4 material gives good rigid thickness material. It's like it's not a plastic, it's not a glass. So something kind of material it is. Okay. So easily you cannot able to, even if you give more temperature or more heat, more pressure when we give this piece, this material will not get rubbery or elastic kind of stuff. Understood, right? So that's the reason this material is used. And one more thing, when we say now I bought in 2022, I bought this laptop. After some 20 years, this laptop become good. Correct? Hello.
Yes, ma'am.
Yeah. So this laptop becomes very old. So at that scenario, what will I do is I will be recycling it or replace with the new laptop. I'll sell this laptop and get new laptop. Correct, right? So what people, they will, same design cannot be used, because in such scenario, in such 2040 and all, the technology would have, it will be double change, it will be there. So we now currently we are into 4.0 industry. Okay. In 2040, we will be in 11 or 12 electronics industry will be there. So in such scenario, everything comes in the touch. Okay, everything AI comes. Okay, so in that scenario, PCB and all will not be there. So in that time, what PCB boards and all we will be doing that. We have to decompose it, right? Somehow we have to throw it out, or we have to destroy that. Correct, right? Hello.
Oh, ma'am.
So in such scenario, when I destroy it, so the PCB smell, when say by government, they are telling we should not burn the plastic, because of when it decomposes, the smell from the plastic, right? So that people should not sneeze that. They should not take intake of that smell. So if they take intake, they obviously get, because of that asthma will be there, because of that smell, you will get the cancer, different type of cancers will be, it will come. Okay, hello.
Yes, ma'am.
Okay, so that's the reason people they tell plastic we should not burn. Okay, so plastic we should not use. So this, when we recycle it, this smell, right, it will be very less when compared to plastic or other material. Okay, so the wastage they will be, when they are doing it, they should, it should not harm use environmental. Okay, so that's the reason they have selected this material for as a substrate material. Understood, right? Why they have used?
Yes.
Hello.
Yes, ma'am.
I'm hearing.
Yeah. So, and one more thing is, this is rigid type of PCB. Rigid type of PCB is you cannot able to bend the PCB. It is like a straight. Okay, straight rectangle or circle shape it will be, but you cannot able to bend that, fold it PCB. Okay, you know one more different type of PCB it is available, flux PCB. You know? Hello.
No, ma'am.
No, ma'am.
Okay, so example, everybody are using laptop, right?
Yeah, ma'am.
So how are you? You are bending your laptop, means once everything is done, once you shut down, you will close your display, correct, right? How are you doing that? So how the, see, everything it is there, the battery and other stuff, everything it is there in the keyboard side, correct? Only monitor and then display section is available on the other window. Only you can able to fold it, correct? So how the connections, wire connections are going from this board to other board, you know?
No, ma'am.
So that is like a flux kind of PCB. So I'll just show you how flux PCB will be. Okay. See, you're able to see? You're able to see?
No, ma'am.
I'm not able to see.
No, ma'am.
You're able to see now?
Oh, ma'am. Yes, ma'am.
So this is the flux PCB. This is how it will be there in the monitor to keyboard.
Okay, ma'am.
Understood, right?
Oh, yes.
So how PCB here it is bent. This is rigid PCB. Okay. And this is from here to here the connection it is. Say example, camera. Camera is rotating, right?
Yeah.
So how it is rotating? So based on this kind of cables. Based on this kind of PCBs, not cables, sorry. Okay. This is rigid PCB.
Okay, ma'am.
Understood, right?
Oh, yes, ma'am.
Okay. And one more, this PCB is done. So you know ID card, right? Every company has their own ID card. So punch in and punch out is there.
Yes,
Correct,
ma'am.
right?
Yes, yes.
And everybody has nowadays, everyone has a ATM card, credit card, everybody has, correct, right?
Yes.
So that is also made of PCB only. PCB not, it is a antenna card. Okay, you will have the chip detected over there. Understood, right? Whenever you plug it there, you will get the supply will come from that, and then it will read the number, card number. Okay, so that's the thing this gives. Okay, see, if you go and keep it your ID card somewhere, will it detect? No, right? Only transmitter and receiver side it detects, correct? No. Hello.
Yes, ma'am.
Yeah. So that kind of PCBs and all, that kind of PCB thickness will be 0.8 mm thickness. Okay. Normal standard board, when we consider it is 1.6 mm thickness. Understood, right? Hello.
Yes, ma'am. Yes, ma'am.
So just want to check. So how is the flow? It is, you are okay, or still I need to improve, or you
No,
are
ma'am.
doubts?
It is okay, ma'am.
Okay, right, everyone?
Oh, okay, ma'am.
Yes, ma'am.
So if you want like a little explanation, more explanation, please let me know. I'll explain properly. Okay.
Oh.
Yeah.
Okay,
So
ma'am. I did.
Yeah. So
Okay,
this is one of general purpose PCB where you will have a single side only. The FR4 material will be visible out. Other side will be you can able to the solder mask opening will be there. You can able to solder the pins or component. You can insert the leads in this hole. Other side you can able to solder it. So this is an example for single side board. So the plastic side means plastic not this FR4 side they will be placing the component. The other side they will be soldering it. Okay, so this is the cheaper. It's like for 1 rupee you will get this kind of boards. Okay.
okay, ma'am. Okay, ma'am.
So this is one kind of just general purpose board. You can rig up the circuit. Okay. So
Okay, ma'am.
we will be using this. Next is copper layer. So copper layer is the next layer is a thin foil copper. Say example thin foil in the sense so 1.6 mm thickness. Okay, your PCB it looks 1.6 mm thickness. So the core layer the means FR4 layer will be like example it will be 1.4 mm. Okay, it will be 1.4 mm thickness. It will be there. Remaining 0.2 mm only will be other material.
Okay, ma'am.
The example,
Okay, ma'am.
this will have this thin layer is like your one single hair is how much thickness.
Yes,
That
ma'am.
much thickness only the copper layer will be there. So
Okay,
they will calculate with respect to the ounce. Okay, copper thickness they will calculate with respect to the ounce, 1 ounce or 2 ounce or 3 ounce or 4 ounce. So 1 ounce in the sense one single layer. Okay, and 2 ounce in the sense two single layer. How much thickness it is there? That thickness it will be there your PCB. Okay.
Okay,
So
ma'am.
the next layer is a thin copper foil which is laminated to the board with heat and adhesive. Say with the FR4 material, they will put some glue kind of stuff, and then next with high temperature, okay, they will make it. They will add this, and on common double side PCB in the sense both the side one single substrate will be there. Both the side the copper layer will be there. Okay, in the lower cost, the electronic gadgets PCB may have copper on only one side. When we refer dual or two layer board, then the copper on two layer. Okay,
Okay, ma'am.
understood, right? So now
Yes,
it
ma'am.
is two layer means both the side copper will be there. Say example, if it is 4 layer, then top layer, substrate layer, inner one layer, substrate layer, inner two layer, substrate layer, bottom layer. Understood, right?
Okay, ma'am.
Yes.
This is substrate layer, okay, and this is substrate layer, and this is substrate layer. So you will have top layer, and then inner one layer, inner two layer, and bottom layer. Understood, right?
Yes, ma'am.
So these are the layers. Now the copper thickness can be varied and specified with respect to ounce per square feet. Okay, copper thickness. Copper thickness is nothing but here. You are able to see this copper thickness, this thickness. Okay, this orange color thickness. How much is the thickness? So that with respect to the copper ounce, say 1 ounce copper in the sense it is equal to 35 microns thickness, micrometer thickness. Okay, 1.4 thousand of inches. Okay, one thing. Next is 2 ounce copper in the sense 70 microns meter, micrometer. Okay, 3 ounce copper means 105 micrometer. Understood, right? Hello.
Yes, yes, ma'am.
So why we will be using 2 ounce, 3 ounce copper? Where we will be using? You tell me if you know. Hello.
Ma'am, when we use the more layers, we can use this thickness, ma'am.
No. Say, you know the difference between gaming laptop and normal laptop?
Yes, ma'am. Their specification is high in the gaming laptop, ma'am.
High speed ports.
No, not high speed.
Compared to normal laptop, the specification is more high and
What
effective in game.
specification means? What is that specification? Exact. Only one thing only it will be specification. Which is more?
Don't know, ma'am.
Okay. So whenever you open even normal laptop, if you open multiple software, what will happen?
It will hang, ma'am.
Okay. Next.
It is the process will slow down, ma'am.
Correct. Yeah, true. Next. Your current consumption is more. Due to that, your fan will turn on. Correct?
Yes, yes.
Yes, ma'am.
Did you observe any time, even in the PC or laptop, anywhere it is?
Yes, ma'am.
Correct, right? Say example, now this Altium software or OrCAD software, when I open with all the application running, so initially when it turns on, right, your application boots, right, that time your fan goes to peak level. Means your current power goes to peak because all the features are enabled during your power on time. Okay, so you need to withstand your current rated for high current. So it has to, so when it comes to high current, more heat dissipation or power dissipation will be there.
Okay, ma'am.
When it comes to power dissipation, so how it will cool it up. So by turning, it will have the sensation, immediately the fan will get turned on and then the heat will get released. Correct, right?
Yes, ma'am.
So this is normal application. So when we come to gaming laptop, so there the current rated and battery, say example, gaming laptop battery, it's like a standard battery only. Do you agree? The size of the battery remains same. Only the weight of the battery, it varies. Correct, right? Hello?
Yes, ma'am. Yes, ma'am.
Any gaming laptop and normal laptop charger, if you take, weight of the charger varies. But size of the charger slightly varies, but weight will be, there will be a difference will be there. Correct, right?
Yes, ma'am.
Yes.
So in such scenario, normal laptop power consumption, battery consumption will be like 70 watts. So whereas gaming laptop, it will be 120 watts.
Okay, ma'am.
So there the current will be double time. So in such scenario, the same design, if you give for copper thickness as 2 ounce, then you can utilize for normal laptop charger can be used for gaming laptop. Understood, right?
Yes, ma'am.
So that is the only difference. Got it, right?
Yes,
so
ma'am.
that's the reason. Only thing is we are going for the 2 ounce copper.
Okay, ma'am.
Okay. Then next is solder mask layer. So solder mask layer, why we are using this, as I said before, just to avoid the accidental contact. Okay. So the layer on the top layer of a copper foil is called solder mask layer. Just the layer gives green color, red color, blue color, black color, white color. So different kind of PCBs colors are there. Okay. Normal standard we use it for green color only. It is overlaid on the copper layer to insulate the copper traces from the accidental contact with other metals. Okay, and other metal, solder and conductive bits. Okay, so conductive bits which I am telling is screw, nuts, other stuff also.
Okay.
This layer helps user to solder to correct place at prevented solder jumpers. Okay, so in this particular area, if you want to solder, you can place the bug strip here and you can able to solder the component. Okay, understood, right?
Yes.
Yes, ma'am.
Hello?
Yes, ma'am.
Yes, ma'am.
Understood, no?
Yes, ma'am.
Yes, ma'am.
The next layer is silk screen layer. The silk screen layer is used to indicate the letters and then numbers and then what is the section. This is power LED means indicate the power, orientation of the component. First pin is where, pointing out which board it is, which version of the board. So board name, everything we can able to do it. Hello.
Yes, ma'am.
Okay, and next is your company logo, and then if any board number need to be returned, say example, this board is working fine, tested okay, that also you can able to write it out. Okay, on the
Okay, ma'am.
silk screen layer. Understood, right? So a silk screen layer normally it will be in the white color. Okay,
Okay,
understood, right?
Yes, ma'am.
Till now you understood, right? Whatever we have discussed.
Yes, ma'am.
Yes, ma'am.
Yeah, Pratyusha, you.
Yes, ma'am. Yes.
Yeah. So these are the 4 composite layer. Mandatorily, you need to know these layers to design the PCB. Understood? No.
Okay, ma'am.
Next, we will just see the terminologies. Okay.
Okay,
So,
ma'am.
shall we take break? Tomorrow we'll see, because so many terminologies is there. Each and everything I want to explain. Okay. Is that fine?
Okay, ma'am.
Okay.
Yeah. So just understand. If you have any queries today in today's session, please make a note. We will start like 10 minutes. We will have for and answer session, and then for remaining session. Okay.
Okay.
Okay. So everybody, I think hope you are you then you are able to make it out. Correct, right?
Yes, ma'am.
Okay. So do you want any improvement? Please let me know. Further classes, I'll help you out. Okay.
Okay, ma'am.
Okay.
Ma'am, I
Good.
have one doubt, ma'am.
Please tell me.
You have told no, ma'am, thickness 1.6 mm. 1.6 mm, you have told the thickness, no, ma'am. In a FR4 substrate.
Board
Hello,
thickness.
ma'am.
Yes, board thickness.
Ma'am, total board thickness is 1.6 or FR4 subset is 1.6, ma'am.
No, total board when we
Your voice is breaking, ma'am.
is it audible?
Now it
Is
is
it audible
audible,
now?
ma'am.
Hello.
No.
Yes, ma'am.
Say example, it is overall
I'm breaking, ma'am.
Ma'am, couldn't hear, ma'am.
Is it audible now? Hello.
Now it is audible, ma'am.
Okay. Say example, now it is overall thickness. Okay.
Okay, ma'am. Okay, ma'am.
It's like a silk screen top, silk screen bottom, solder mask top, solder mask bottom, top layer, bottom layer. That will have only 1 ounce thickness. 35 microns only it will have.
Okay, ma'am.
Okay. More apart from that, 35 microns for 2 layers. Okay. And 0.01 microns is for solder mask layer, and 0.1 micron is for silk screen layer. So 0.2 and then 0.02 and then 0.018 and 0.0035. Okay. So it will be hardly 0.2 mm only it will come. Or 0.1 mm it will come. Okay, 0.127. Remaining everything it will be your FR4 material.
Okay, ma'am.
Okay, so that I will explain you during the stack up when we go for the design, right?
Yes,
Why, how the stack up layer it is, that time I will explain you. Okay.
Oh,
so then
okay,
you will understand in the tool you will have the layer arrangement.
Okay, ma'am.
By default, it will be there in the tool itself. Okay.
Okay, ma'am.
Excuse me, ma'am. I just want to know which tool we are using. We are going to use.
Allegro. It's the OrCAD. Cadence.
Okay. Which version, ma'am?
16.6.
16.6.
Do you have?
I have, ma'am, which is 17.4, ma'am.
17.4.
Um,
Everybody has 17.4 because I don't
No.
have setup for that. If you have your
No.
setup, can you share with them? Hello, Pratyusha.
yes, ma'am.
If you have that setup, you please share with them. They will download from that link, and then you guide them how to install also. Okay.
Okay, ma'am.
And yeah, one more
I
thing
got it
before
from
downloading
YouTube,
it.
ma'am. I
Yes, yes.
will share the link. Okay.
Yeah, I just want to know both of them. What is your system system configuration?
I don't know exactly, ma'am. I will.
Actually, for 17.4, you required minimum 8 GB RAM.
Yes, ma'am. Yes, ma'am. 8 GB.
You need a maximum 16 GB RAM, else system will get hanging.
Okay, ma'am.
You
I
need to
just
make
check.
sure. Yeah, you
ma'am.
have to make sure that that is happening, because I cannot able to install some hanging is happening in my system. That's the thing. I could not able to install 17.4 or 17.2. Only 16.6 I'm able to install. I tried n number of times. I don't know why it is not installing, but I can explain. I have worked on 17.4. I have worked on. I'll explain in your PC itself.
Okay, ma'am.
Okay, ma'am.
Okay. Any one of you, if you give control, no, so that I can explain.
Okay.
Okay, ma'am.
I don't have any issues. Okay.
Okay, ma'am.
Only GUI difference would be there. That
Okay, ma'am.
totally different when compared to 17.2 to difference is there. Huge difference. GUI. Okay. If you could able to install, please try to install it.
Your voice is breaking.
Voice is breaking.
Yeah, try to install. I'll make sure from tomorrow I'll make sure that my internet is working fine. Okay.
Okay, ma'am.
Yeah. Okay then. Bye. If you have any
Okay,
doubt,
ma'am.
please let me know, or else please wind up the session. Okay. Okay then.
No
Bye.
doubt,
Good
ma'am.
night.
Okay, ma'am. Bye, ma'am.
Okay, good.
Thanks for watching Introduction class. If you want to register, please visit dridhOn.com. Or you want to discuss more or check for the trial classes, please call 9066508122 or visit dridhOn.com. Thank you.